Hello, my name is Hugo Magalhães and I am a railway engineer in MainRail. In this video, I will introduce our Vehicle Track Damage tool, abbreviated as VT Damage V01. The main goal of the VT Damage is to predict damage of selected assets, avoiding their failure and optimizing maintenance activities. The VT Damage takes into account the railway operations, considering real data that is generated from the client and synthetic data that is generated through computational simulations as the one shown in this animation. All this is then used to predict the remaining useful life of selected assets. Examples are wheels, rails, track. The remaining useful life is given as function of time, travel length, or MGT. The VT damage uses health condition indicators that are defined as required. The evolution of the HCI, health condition indicator, over time is monitored, enabling the prediction of the remaining useful life. This graphic is an illustrative example that shows the evolution of HCI over time. Note that 0 means no damage and 100% means failure. Additionally, a threshold may be specified, meaning that when the threshold is reached, an alert is made. Examples of health condition indicators are wear measurements, dimensions of crack depths, track irregularities, and voids under hanging sleepers. Here is a full description of the VT damage. First, we request for real data that is provided by the client. Then we set up the inputs which will run the VT damage. The VT damage can consider multiple scenarios. In this demonstration, scenario 1 represents a vehicle running in a track. The first step is to run multi-body simulations like the one shown in this animation. The results obtained from the multi-body simulations allow us to assess the vehicle-track interaction. This information is then used in the damage prediction module. In this demonstration, it is shown wear evolution of the wheel. Let's zoom in on the wheel tread to show the removed material. After this iteration, the health condition indicator threshold is tested. If it doesn't reach the limit, then it goes to the next iteration. In the next iteration, the wheel or rail profiles will be updated to consider the material that was removed. And the process is repeated until the health condition indicator reaches the limit. The remaining scenarios are considered, for example, to represent alternative scenarios where it is considered different wheels, different rails, different vehicles, etc. Then, all health condition indicators are analyzed and the best scenario can be identified. At this stage, plenty of data is generated representing the information from the different scenarios, results from the multi-body simulations, and also results from the damage prediction. This information, together with the real data from the client, can be assessed through big data analysis, which allows the development of AI model. And the main outcome of the VT damage is a digital twin for the remaining useful life of the selected railway assets. Let me show you a practical example. A single scenario is considered where rolling contact fatigue and wear of rails are predicted. It is considered one track like the one shown in the slide. Two multi-body simulations are run for each iteration. MBS1 considers vehicle 1 running from A to B 20 times per day. MBS2 considers another vehicle, vehicle 2, also runs from A to B but only one time per day. In this case, cracks and wear on the rail are monitored for the whole track. The results show that crack appears on the low rail at the curve transition, as shown in this figure, and the rail profile with highest wear is observed in the high rail, as shown. The VT damage can be validated with maintenance records. In this way, it is possible to predict damage, and then we can avoid failure and optimize maintenance activities, as I mentioned in the beginning of this video. Please contact us if you found the VT damage interesting. Thanks for your time.